That's a skillet. So either way you do this, you're going to get 5 times 8 or 3 2s or however you want to do it so that you have a 2 out here. See how I leave room for all my XYZ stuff? And a 5 is left in there, too bad. Now let the rest of this be relatively easy. 3 goes into 13, 4 times width. 1 left over, I love it. Yeah, 3 goes into 38, 12 times. With 2 left over. 3 goes into 2.
No.
Shit, with 2. Everybody left in there, too bad. Put a times there if you want to. Make it for the room.
It's like so simple it's hard to understand.
Like that statement?
Yeah. It took a half an hour of doing that later until I realized. Really?
It's not that bad. Yeah, once you get this. Normally everybody does really well with this on the test because once you see it, it's there. It's there. So that's enough of that.
Then we get to like G.
Hold on, I'm getting there. Real quick, before we get to G, I'm going to have division. Kind of happy we're not going to talk about that, whatever that is thing called rationalization, because people start to try to do it here, and this is just so much easier than that. What are you allowed to do here, since the roots?
Subtract. No?
How do you mean subtract? Subtract what? Subtract the power, sure, because you're allowed to divide these, because they have the same root, right? So 88 divided by 8? 11. So I went the backwards way, and that was too bad for me. Y7 divided by Y?
Y6.
Good. Z11 divided by Z5? Z6, cool. So what part of that can you do the cube root of? And? Good. So 3 goes into 6 twice, 3 goes into 6 still twice, Jeff. And then it's left inside is a 411 do.
Why wouldn't you, oh, because you can't get 3's out of the better. Never mind.
Alright, cool. Some of you guys might realize I meant to put an 11 there so that we would end up with an 8, but this is even better. Yeah.
So, on all these files, you never like tested, for example, number 11, you never really mess with that? Once you get to that right there?
You can't get 3's out of 11, so.
Yep.
Just the power.
If it's 12, if it's 12, you could.
So it's a lot like this. Now watch. Let me see if we can do this. You can do it, Jeff. Come on. 20 over 9.
Okay.
One way to make this into a mixed number. 9 can't go into 20, but 9 can go into part of 20. Just like, well, it's not a great example for this, but it'll get there. Just like if I had square root of 50. Can I take the square root of 50? Sure.
No. 10 and 5?
Oh,
No.
No.
I can take a square root of a part of 50, and that part 2 would be left inside, right? So here, 9 can't go into 20, but 9 can go into 18. Right? So then I do the part I can, and then the part 2 is left over the 9. I don't know if you guys see, there's a nice analogy there. There's a nice symmetry between those kind of ideas. So if I would have put an 18 over 9, that would have just been 2. Sort of like if I would have said square root of 4, that's 2. But if I put extra stuff inside, so if I put square root of 8, break it down into 4 and 2, much like we had 20, it had extra 2 in it, didn't it? So I did the part I can, and the part that I can't do just gets left. Just gets left behind.
I don't get how you got z to the 6 when
So if I have 11 z's over 5 z's, how many z's cancel?
11 minus 5.
Yeah, or you just subtract powers. Yeah, cool. And I'm allowed to do that because these are the same root. Yeah. All right, so let's work our way now
Well, if
to.
there's no root, it's still considered the same, right?
Yeah, that's what we've been doing forever.
That's right.
So if I had 80 x squared over 8x, can I divide those?
Yeah, it is.
Yeah, because they have the same root, namely none.
Yeah.
So we've known that forever. We can do them if they have the same root. So nothing's changed really. They still have to have the same root, right?
Is there times where you can pull out all, if they all end up being roots and it's not no longer in the.
Oh, sure, yeah. If I would have made that an 11, then I would have had an 8 here, right?
Yeah, then.
Cube root of 8 is 2, there would have been nothing left inside.
Okay, there's
Yeah.
a problem on them. I
Okay?
think it's F.
Yeah, F works that way.
on
Yeah,
4.
exactly.
Okay, that's it.
Good. So now we get our way to something like G. So this is where you just have to realize, what's that stuff? I don't know. Let's see. Ooh, I like it. It's gruesome.
You're missing part of the fraction, like on the x, and you like put a 5 in that or something?
Oh, yeah, sure.
So
Let's see. Let's make this a little worse. Negative 6 over 7. How's that? Thank you. So, mathematical processes don't care what's in it. When I have things with powers being raised to a power, what do I do with powers? Multiply. Period. Math doesn't care that there's fractions in there. We care that there's fractions in there because now I know how to multiply these. So 27. So don't just write 27 again, because everything's being raised to this power, right? In fact, what's right now the power on the 27? 1. So then you multiply the powers together, and then you get negative 1/3. Right? So it's not 27 doesn't act differently than the variables do. It's just that the variables are kind of factored, and 27 isn't. But it's still, whatever the power is on the 27 gets multiplied by the other powers. That process doesn't care. It just, that's how it happens. Then it'd be x to the negative 6/7 times negative 1/3, right? You guys good? Because when you have things with powers, raised to a power, you multiply the powers. And then z9 times negative 1/3.
Oh, never mind.
All right, so let's see. How do I do this x piece? What happens in here?
3 and 6.
Yeah, the negatives cancel. 3 goes into 6 twice, so I get x to the 2 sevens. Because now it just became a fraction multiplication problem. Let that be easy. And over here, what do I get there? Yeah, negative 3. And negative 3 goes into 9, negative 3 times. And then how the hell do I do this?
Then you have to switch.
1 over 1.
That's 3. It's negative.
That's 9.
What's the negative mean?
1 over 27.
It means flip it.
Yeah.
Oh.
And then how do I do a third power?
Root to the
Cube root. So that is a cube root of 27 that needs to be flipped. Bam. Negative power. So there's several commands here. It says flip it, take the cube root. All right, I flipped it. Now I got to take the cube root.
Which is 3.
Negative powers can never make something become negative. They can't. They just mean flip. Good. So on the bottom I got 3. What else should I have on the bottom?
The minus 3.
Yeah, these 3 z's go down because the negative power means
Yeah.
flip.
Yeah.
It could be nut too if they're down.
I
But
know.
they're up, so now they're going to come down.
Flip it.
There's a Abbott Costello machine there somewhere. And on the top I just have
X.
x to the 2 sevens.
Is that from the
That is
work
a
complicated?
It's so complicated, like nobody's gonna get it.
Of course not.
I think I will. Especially people who do the homework. Yes.
Go back over one more time about
Yeah, we're going to do this again.
27 and 1/3 and how you flipped it and made it. That,
What's up?
okay, how did you do this with another choice. 27, negative 1/3 over here, and then, so it's because that negative, you want to bring that negative up to the top, is that what you're doing?
The negative.
27 minus, right there.
Negative power means flip, so it's up top right now, so I brought it down. Alright, so there's several things going on. This is a problem that's got, each piece of it is a problem that we've done earlier separately, but now they're just all together. So you need desperately to be able to do something like a to the negative 4/3. Just by itself. And that's just one piece of this problem. If you're able to do it there, you should be able to do it there. So how do you do that? What does that tell you?
Elevated to 4. Sorry. Flip it first.
Good, alright. So flipping first is a good idea.
Yeah.
So that the 8 4/3 just flips down, and what's the 4/3 power mean? What root? Cube root to the 4th power. So we know fractional powers means roots. There's nothing here that says you have to be able to get to the answer real quick or something. So right? I just rewrite based on what this is telling me to do.
And then it's 2 to the
Yeah. So cube root of 8 is 2.
Do you put the 4 outside every
Yeah,
time?
why do you put it outside?
Because I'm allowed to. And I'd rather take the cube root of 8 than the cube root of whatever the hell 8 to the 4th is. Right? We talked about that before,
But it's
that
the same, right?
you could put the power on the inside or the outside. It's the same.
Okay.
Either way, I am raising it to the 4th power. As long as that happens, it's okay.
Okay.
So now 1 over 2, right?
Well, what's 2 to the 4th? 16. Let's do another one. Here we go.
That's actually x minus elevated to
So real quick, I haven't talked about this yet at all, but there are people that have what's called fixed mindsets, and there are people that have what's called growth mindsets. And the people that have growth mindsets realize that they just currently don't know as much as they will know, and they know that they can get there. People that have fixed mindsets say, you got to be born with this stuff in your head and bullshit, and I'm not that person, so and then you're fixed. You never allow yourself to grow. So I understand that part of it is joking around, but at the same time, when you say something like nobody's going to get that problem, you're not helping anybody out. I understand that statement. Right? Yeah, it better be. But I mean, that I see very few of you in my office. I see very little homework yet. If you turn in all the day of the test and you get it all done, that's okay, but that's not, you really need to get it done sooner. So I'm not talking to everybody when I say something about homework. But there are a few of you that know who you are, that I have no idea how you think you're going to pass this class if you don't do the homework. It's impossible. Ask people that have successfully passed math courses what the hell they did. They started doing the homework. Right? And you come to get help if it doesn't make sense.
Let me add just something, like to myself, I'm not talking about nobody. Sometimes I do the homework, I have some of them, I got 100 times 100. You know why? Because I just follow the few examples. I'm just talking about myself, I don't care about, you know?
Yeah.
Yeah, sometimes, like, these things help you a lot. But on the exam, you don't have nobody, you know?
Exactly.
Sometimes you stop it, you don't know what to do.
True. And that's one downfall of having a help on every single problem, is that you're never really internalizing it. You're just always externalizing it, as long as you have the pattern, and you're not going to get that on its own.
What also doesn't help is, I like doing it online, but the way you teach it and the way online explains it are two different things. So I'm trying to combine both together.
Yeah.
And it's like, oh, he taught.
See, that's why I make it optional. I don't ever see myself making it mandatory, because I'm not going to sit down and write software.
Yeah.
So I'm not going to make something that agrees with the way I teach, and I'm not going to change the way I teach to match with some stupid software.
Yeah, so I try to go back to my notes from in class that day when I do my homework.
Yeah.
To see how you wrote it.
But again, sometimes the way that I teach things, the way that I see things, don't match with the way a student would better see it.
Yeah.
So being exposed to a different way to explain it is good. And I get that all the time. If only you would have said this, and I'm like, I can't say everything.
Yeah.
Right? And I normally go with what makes sense to me, and then I show a few other ways too. Yeah.
Yeah, can you do like an example of 4B? Oh, no, I'm sorry, 5B.
We're doing the letter G first.
Yeah, let me work my way back to there.
Okay.
But are we doing the math practice test?
Sort of, yeah.
Okay.
Yeah, I've got the answer key. That's why I'm not doing those. I've already got those
You
done.
got it?
Yeah.
Okay.
So you'll get that here in a minute.
Yeah.
Let's see. So what have I had? You can do it, Jeff. Can you do it, Jeff? I like it.
So when you bring it up then, you're gonna flip it?
Yep. So in another class I teach, a student told me after the test he was upset because the test didn't look like the homework. So I found homework problems that I assigned that pretty much matched what the test did, and I showed it to him. You know, and I don't understand the level of similarity that's required. You get what I'm saying? So at some level of math, they will look very alike, but then when you get to another level of math, the concepts are more important, so the problems can look very different. But at this level, there's only certain things I can do, and that does not look like something I have on the test, does it? Yes, it does. I don't have anything on the bottom, but who cares? The idea is, what does a negative power mean? Flip it. So it's currently down, so it's going to go. So when somebody tells me I don't have a problem like this anywhere in the homework or something, I'm like, yes, I do. Negative powers mean flip. I don't care where they start. Wherever they are, you make them go the other side. Right? So the idea is what's important. So this, the first thing I can do is make this 27 to the 2/3 positive, because that's done its job, right? If I made it negative still, it would like bounce back and forth and never stop. I don't like it, I don't like it, I don't like it, I don't like it. So it doesn't like it there, it's going to like it up there. It just is. Or it's going to hold its peace. So yeah, how do I rewrite this? Good. Cube root.
Of 20.
So cube root.
27, that's a great.
Yeah, would you rather put it in there?
No.
So now it's 9.
Cube root of 27 is?
3.
Takes 3 3s to multiply to 27. Real quick. Watch this. Let me see. Just in case you guys get this. What is 27 made of? Break it all the way down. 3, 3, 3. So 2/3 of that would be 2 3s, which is 9.
Mind blown.
So I love that. I mean, that's 2/3 acts like 2/3 in front of something does additively. So 2/3 of 9. 3 plus 3 plus 3 is 9. So 3 plus 3 plus 3 is 9. So 2/3 of it would be 2 3s, which is 6. That's another way you can look at that. Or you just do that, right? Either way you look at it, you get 6. So it's interesting, multiplicatively, if I break that number down multiplicatively, that 2/3 acts exactly like that 2/3 does, just based on multiplication. I'm not trying to make this harder, I'm trying to show you how there are other ways to look at this. Now, if that didn't make a damn bit of sense, forget about it. It's just one way to look at it. You don't have to look at it that way. So I always get somebody says, you didn't explain it well enough, and somebody else says, you didn't stop soon enough. You explained it too much.
I'm sure to shut you out as soon as I understand what you're saying.
Alright, so the final step here. So if I had 27 x to the 4/5, y to the negative 3/7, to the negative 2/3. Does something look sort of familiar? Not exactly familiar, but sort of. Right? Isn't this going to be 27 to the, which is the reverse of this, is going to end up going down, right? But still.
Now we can.
So this is 27 to the negative 2/3. You can do that. What happens here? What happens here? Yeah, when I raise something with a power to a power, I multiply the powers.
So I think we can bring the whole thing down, right?
Yeah, you could, but there's one of them's negative already.
So that
So
won't change if we do that?
if you flip everything, it just makes it weird because then people make that positive, but that should stay negative because it didn't flip because of this.
Okay.
So if you can keep that straight, great.
Okay.
To me, if I have something like this and some of them are negative, I bring that through, and then the ones that are negative just go down at the end, right? Either way you want to do it, it works still. So what? How can I write this? X to the
4/5.
yeah, and then y to the okay. So that's just the apply the property step, and then you work each piece out, right? So if I added a few more letters, people would go, "Oh, that's hard." That's not hard. It's just a couple more things you got to write. It's not any harder. It's just a little bit more to write. Yes, sir.
And in this one, you have to do it so it's the simplest one.
Yes. So what happens here?
And it goes down.
Yeah, it goes down and it becomes the
The cube.
cube root.
27.
Hey, Jeff?
Yes, sir.
Right there, I kind of lose you every time you say, okay, this goes down. So meaning that, just draw a line and put it on the bottom of the line?
Yeah, because what's always down?
1.
1. So now that just goes down and multiplies by the 1. There's always a down. Always. We just don't always draw it, because why would you put 4 over 1 when it's just 4? But there's always a basement, right? It's always there. So that is up. If it's to a negative power, it wants to go down.
Okay.
And everything else,
You can't have a negative power, right?
Say again?
like,
Yeah, we don't like negative powers. We flip it
Yeah.
as a last step. Or in the middle somewhere. So what happens here?
Minus.
Yeah, negative 8 over 15 because nothing cancels. And then here,
2 over 7.
yeah, the negatives cancel, the 3's cancel, so you get y to the 2 over 7.
So the X
Oh,
goes
that,
down.
that X minus.
Go ahead, Carl.
The other one's staying on top.
Because it's
Oh, I haven't moved it yet. Yeah.
Oh.
Yeah, I saw that was a negative power, so I brought it down. I still had to work that out to see what it became, and now I can bring it down. Yeah. Good. So that
Goes down.
was down. What's this? What's the cube root of 27?
3.
Squared. It's a 9. This wants to go down with it. And what's left up top?
y over
Y to the 2 over 7. That's it. Just
Can
that
we keep
easy.
those in fractions?
no,
Or we have to do the...
No, you can leave it as fractions.
okay.
Yeah. Normally, if it starts with fractions, you can end with fractions.
Oh, okay.
If you made them in the roots, you wouldn't be wrong. There's just no reason to do it.
Put it back in the root.
Good.
On the y, 3 over 7, multiplied by the, yeah, that, what is that? That bottom one, there's 2/5. Or I mean 2/3, right?
Yeah? So the 3's cancel?
Oh, I get it.
Because you're
I
multiplying.
missed that, yeah.
Why did you bring the X down?
Because it was to a negative power.
Negative power.
Oh.
And negative power means flip. So technically, you're not wrong if you leave it up here. But at the same time, it's not right because convention says don't end with negative powers. Put them where they want to be. Yes?
How can you do X or 15X?
You could. That was the question. This is acceptable way to represent that, and also you can make it the 15th root of x to the 8th. That's another acceptable way to
And then
represent
you
it.
could also do the same thing to the Y.
Sure, of course. So you could make this into what root of y?
7
7th root of y
squared.
squared over 9.
But then you can use
Root 15 of 8.
Mama.
You could put the 2 and the 8 power on the outside, but in this case there's no reason because I don't care. I don't have to go any
I
further.
was going to say, can't you pull out, but never mind, it has to go to the 7 15.
Alright. This is one of the more difficult problems. I think, have you picked up on that?
Yes.
Right? There will be a problem much like this, but it will be one amongst many slightly easier problems. This is hard because it's got several ideas at once. But the people that are better at math are the people that kind of naturally break things up. Right, that makes life easier if you can break things up. If you don't do that naturally, you have to force yourself. That is a problem. I can do that problem. That is a problem. I can do that problem. Right? Force yourself to look at it like several small problems.
They have that on 12.5 where you FOIL.
Oh yeah, yeah. So that's
That was very difficult.
okay.
I did it, but yeah.
I like it. Good. Yes. You good? Okay.
Questions from
What
homework?
you're saying,
Questions from homework?
Okay. Oh, is it from?
Yeah, from the homework, so I don't know what you were thinking.
Graphic. 12.2.
what are
Yeah, there's
Right.
graphics on there. I didn't do it.
Oh yeah. Shoot. I wasn't very careful when I. If they ever have a problem that says use a graphing calculator to do this, just skip it.
Okay.
You're not allowed. You're not allowed. You're not required to have a graphing calculator
I have a
yourself.
question of the same section, number 112.
Okay. So this is section 12.2.
Yeah. This is letter F to L.
Hold on. Let me get there.
What page is it? I don't know, page is.
739. Okay, section 12.2, page 739. Number, what was it, 112?
Yes.
Yeah, the same.
Oh, that would be.
The trick here is to not overthink. You actually don't have to solve some weird ass inequality here. Just what would you plug into X to make this negative? So really, what's that 1/3 power? I know it's a negative power, so it would flip, but who cares? We're just talking about signs here, right? They're asking when is it going to be positive? So I'm going to think, okay, what X is what I have to actually put in there to make it negative? And the answer is everything else. Or if they're asking when is this positive, let me figure out when is it negative. And I'll say it's everything else. So what do you take a cube root of to have a negative answer? A negative number, right? This is the only way. Cube root of 0 is
0.
cube root of 1 is, cube root of 8 is 2. If I take a cube root of a 0 or a positive number, the answer is positive. The only way it could be negative is if it starts off negative. So what's really saying is what inputs will make the output of this positive?
A positive.
Positive ones will. The only ones that will make it negative are negative inputs. So when X is greater than 0, then this will be positive. Because the only way to make this negative, so if I rewrote this is 5 over this, right? Because the negative power makes it flip. And what is X to the 1/3?
Square root of.
Cube root.
Cube root of. X.
So the only way to make this negative is if the cube root of X is negative. And when is the cube root of X negative? When X is negative. So how do I make it positive? I just make sure that my X's that I'm plugging in are positive. And that's the only, that'll keep all the answers positive. That was definitely one of the last problems, so it's almost certainly going to be a freaky one. But it wasn't that freaky. It was a little freaky to get over, and people get freaked out about that. That has nothing to do with the sign of this. It just flips it, right?
That seems like extra credit.
Definitely. But you have to feel free to just explore an expression. This is something you don't know you can do in math. It's a requirement when you get a little bit further up in math to play with it. Believe it or not. And you're like, what the hell would that even look like? You got a bunch of numbers. Hey, I'm going to kill you. No. You just try something out and just see what the hell happens. And think about, okay, what are they asking me? And so this question really is, when is the function positive? That's a way to reword that in English. And that actually makes it easier to think about. How do I make sure that this is positive? I just only plug in positive numbers. If I plug in a negative number, it's going to become negative. What's the cube root of negative 8?
-2.
See, I can't plug in negative numbers if I want to force my outputs to be positive. I can only plug in positive numbers. Okay, but that was a weird one.
So Jeff, you said number 6, the graphing is not going to be on the exam.
What's that? Sorry?
Number 6 on the practice test.
Why would that not be on the exam? When did I say that? Oh, I think you're reminding me about something.
The graphing.
Why would that not be there?
No, he said if you have a question that asks for a graphing calculator.
Oh yeah, you don't have to use graphing
You
calculator.
don't have to do it.
Exactly. You don't have to do graphing calculator work.
If you say whatever you don't like on the test, you skip it. You don't have to do it.
Listen to Carl. Okay.
Can you do number 40 of 12.4?
40? All right. Let me do two things real quick before I do that. So I got a little list of questions from Aveen, and that question. Let me do two things. Let me give you the answer key. And I just now remembered, I thought this is what you were asking. I'm like, you don't have the answer key. How would you know this? I only went up to number 5 on the answer key. I want to do the rest in class. So we'll do that together real quick to make sure we all have that. 2 reasons I did it. Save paper and because I was tired.
So when you're dividing square roots with the same root, or roots with the same, I don't know. They have
Roots with the same index.
Yeah, with the same index, you automatically have to divide first and then give it.
That's a good idea. You're allowed to. So if you can reduce anything, you definitely want to do that first.
And what if the answer doesn't relate to nothing?
That's okay. Then you're done. Right?
The one that I asked.
One more that way. Right here next to you. Oh, somebody there?
No.
There you go. Cool. All right. There's a method to the madness. All right, so let's do the last few. So I have it. So you'll have it. It'll be on camera. So starting at number 6, the graphing problem. What's up? Sorry. So 6. I really want to get you guys to the point where you graph lines in a certain way. I mean, the quickest way to graph a line is to do what?
The X and Y.
I like that. I always have somebody say, get a graphic calculator, tell you. But no. You solve for what? Right. Solve for what? Period. You get your mx plus b. Go from there. 2 reasons I want you to do that really. You could find x and y intercepts and do it that way, but sometimes they could get gross. But you need to really reinforce the ability to find the slope and the y-intercept because it's going to be built on later. Right? If anybody's going in for... Everybody's got to take 120, 160. Right? Is everybody planning on doing that? Mm-hmm. If you want to transfer a math course, you probably want to do that.
120, sorry.
Yeah, 103 leads to 120 or 160 or 125, and then you can do an elementary education.
By the way, do you teach 160?
What's that?
160?
I teach stats, yeah.
Yeah?
Stats is awesome. I used to teach 120. I haven't taught it in a while, but it used to be my favorite class. It still kind of is. I just haven't taught it. Because you get to teach Babylonian numbers and Egyptian numbers and stuff like that.
So are you doing this semester? Summer?
Huh?
Summer.
I have no idea what we're doing this summer. Yeah.
So you need both of those to transfer?
No, either one.
Oh, just one of those.
Those are the 2 of the first of the transferable level math courses. Yeah.
1/6.
So if you thought you were there, you're not. Sorry. So if I solve for y, I'll get this on the first dude, right?
Yeah.
Just cut to the chase. On the second dude, I'll get that guy here, right? If I solve for y. I know you all can do it. You can solve for y. If you can't, don't tell me. Or tell me, come to my office immediately. So what's the y-intercept for the first dude here?
Go
0,
4.
What's that? So 4.
Down 4. It's negative 4.
Oh yeah.
4, yeah.
Negative 4. And then I want to go
3
up 3.
right 1.
You know what I mean?
And just make sure, I mean, you know this is a positive slope. So just take a second to make sure that it actually is going up as you read, right? So if you get this, you know something went wrong. Don't do it. And what kind of line should I make?
Dotted dash.
Dotted dash. That's dotted. And how do I figure out which way to shade?
Find a 0 point. Or,
Test it.
yeah.
Right?
0.
So is
0's not in it, so you can.
exactly. Doesn't go through 0, 0.
So let's check it that way.
Yeah, so if I put 0 greater than 0 minus 4, that's true.
That is true.
So then I shade out. I love it when people say false. And no, you should look at it. Think about it. You should know that. So this guy, what's the y-intercept?
Up 3. So that's
Good. 3.
Down 2 over 3.
Good. Down 2 over 3. It's a negative slope and I'm going down. Good. And I want to make so a line. Because like Carl said, if you see a line, make a line.
Yeah.
Alright. Sounds something like
So the 0, 0
New York.
down 2.
if you see something, say something.
So it goes down. You shake out.
Yeah, so if you test out a point is 0, and it doesn't go through 0, 0, so I can use 0, 0. Is 0 less than equal to 0 plus 3? Is 0 less than equal to 3?
Yes, it is.
Yes. So I want to shade in the direction of 0, 0. And then just make that part nice and dark. Because that's where the two shadings overlap.
That's not too bad.
So it means every single point here, that point works, that point works, you get a car, this point works, right? If I plug it into this, it's going to work in both. This right there, what would that point do?
Nah.
What would it do exactly?
It's messing the whole graph up.
It wouldn't work.
No, it's just sitting there. It's not messing anybody up. But if you try to plug it in, it would not work in.
It will not make sense.
It would not work in either one because nobody shaded over there, right? Nobody works over there. You guys with me? All right. So I want to really double shade the part that is the answer for the whole system. Something that makes everything work. All right. How's that by itself? Is that cool? So you know you're gonna have a problem like that.
Hey, the solid line means it goes up to it but doesn't meet it. And the
No. Solid line is like filled in circle.
Okay.
It means all the points. This point works in that equation.
It's the dash line that means
Dash line means this point does not work in the equation.
You can adapt it like a 3.99999 and it will still work.
Thank God that's what we have like parentheses for.
Yeah. Huh?
That means almost this. Yeah. All right. So what about number 6 that references two, I think, word problems in the book?
Yeah. Laura didn't understand that.
Yeah, I didn't understand that. I was like, what do you mean?
I wrote no solution over that, Jeff.
On the line,
What's that? I'm
the
sorry?
one that is not dotted, the second point, yeah, it's that
I don't
one.
know what.
This point?
Yeah.
I think let me see. So it was down 2 over 3. Right? Down 2
Yeah.
over 3. So that's where that point came from. Down 1, 2, over 1, 2, 3. Pop. This point was just later, I was just talking about this. I don't know if that's the point that's messing me up. I just put it there when I said that point would work. Yeah.
Just a quick question for the test on Thursday. How many word problems do we have?
7.
Oh, man.
We don't have any problems, right? He was just saying.
Wait, so we got 7 of those.
The problem is you don't have enough time.
At most 2. Come on. Especially the people that have had me before. You know I'm reasonable. I know you're just bullshit.
Yeah.
You know I'm
You're gonna
reasonable.
get at least 1 or 2 under each other.
Or you know I'm not. I don't know. So I'll give you at most 2 word problems, just like on the tester. Huh? Aw, this is not open for debate.
All right, so let's practice. At least one now.
What's that?
Let's go over at least one now.
It's not.
At least what? Sorry?
At least
At
Word.
least one.
we're doing both of these.
All right.
Yay! Because that's what I said we'd do. Let's see. So this is page 499. Oh, it's awesome. Number 22. This is number 6 on the practice test, right? The second number 6, because I like the number 6, so don't give me credit. So 22 says, copy quick, has 2 copiers. One copier can do a report in 20 minutes. And one copier, the other can copy the same document in 30 minutes. How long would it take both machines working together to copy the report? I want to see this. So you just throw that report in the room and say, work on that.
0.
They're done, right? Why room there? So how do I set this up?
1 over 20
Yeah, one report in 20 minutes.
1 over
plus
30.
1 over
Working together with this one that can do one in 30 minutes.
equals 1 over 10.
They can do one report in I don't know how many minutes together. Cool. And then how do you solve this?
LCD.
Maybe.
Since you're adding that LCD.
Maybe
This
so.
is 5,
What's the LCD going to be for the numbers?
5.
No, 6.
No, the other way. Not the number that can go into both, but the number that both can become. They can both become 60.
Oh, I'm sorry, yeah, 6.
That's right.
20 is 30, right?
So so it's going to be 60
X.
X. So what's he need?
30.
He needs a 3
And
and an X. He needs a 2
20.
and an X. He needs
60.
a 60. So now I can multiply by 60x and kill all the bombs, right? So beautifully now the equation is you can kill any fractions in there. So you get 3x
plus 2x equals 60.
It's crazy. 5x equals 60, so x equals 12 what?
Something's.
Not copies. Minutes, good. Don't forget your units, or I will be a complete dork. And put 12 bananas.
Those are the work files we're going to have, though, too, just like that, right?
Yeah, that's one type.
What?
Yes.
I used how the book explained it, and I got 12. But
How the
I
book
didn't put the X in the bottom.
Oh, you put the x on the top?
Yeah.
All right.
Is that fine?
That's fine. Because then you would multiply by x and they would have to compare.
Yeah.
All right, so what about 24? Ryan drives 20 kilometers an hour faster. 20 kilometers an hour faster than Alicia. So let's start to fill in our little shark here, right? What's the equation?
R plus T equals V or something like that?
No.
Rate plus time. Time plus rate.
Dirt. All right, dirt spelled D-E-R-T. E for ears. Dirt. So what do we got? We got Ryan and we got Alicia. What do we know about either one of them?
Total 1 kilometers.
That's useful. That's actually useful. We don't have to change from miles to kilometers. It's good. Good job, Carl. Somebody got their book open? Somebody can see. Somebody have a book?
No.
So it says Ryan drives 20 kilometers an hour faster than Alicia. I guess nobody tried this problem either off the practice test. And the same time that Alicia drives 225 kilometers, Ryan drives 325 kilometers. Find the speed of each car. So we know that Alicia drove 225 kilometers. So where did I put that?
Distance.
Good. And Ryan went 325 kilometers. And I know that Ryan is going 20 kilometers an hour faster than Alicia. So how fast is Alicia going? Good, because I don't know. And then Ryan's going 20 kilometers an hour faster than that, so he's going...
X plus 20.
I like it. And how do I fill in that? If distance equals rate times time, time is distance divided by rate. So this would be...
325 over X plus 20. And 225 over X.
And it said in the same time...
That's mean equal.
Good. It means the times you set them equal to each other. If it would have said in a total of 10 hours, you would have added the 2 times and set it equal to 10, right? So it all depends on the relationship they tell you about the last boxes you don't have filled.
So when it says a total of 10 hours,
You would add them together to make 10.
So it would be,
It would be this plus this equals 10.
and to add those together, you have to have combination.
LCD.
Okay.
And since it's an equation, you can actually just kill the bottoms once you have an LCD. Right?
Wait, say that one more time. That plus that equals 10.
If they said the total time it took for both was 10 hours, you would say this time plus that time is 10. Now, in this case, they say in the same amount of time. So this time has to be equal to this time. That's your equation. But your equation comes from that relationship they put on the last boxes I fill in. That's where your equation comes from.
So wait, can you read just the question equal?
Say again, sir?
Can you just read the, and then you find that each is missing?
Ryan drives 20 kilometers an hour faster than Alicia, and the same time that Alicia drives 225 kilometers, Ryan drives 325 kilometers. Find the speed of each car. Of course, it makes sense. Ryan's going faster. He went further.
So now we can just multiply them, right?
Beautiful. You can cross multiply. You can. And be really careful. When you cross multiply, your equation better still exist. You can't make your equation not exist. I always get somebody to put the x up there and the 225 down there, and they get this weird looking little fraction. They circle it. I didn't know. It didn't tell me how fast anybody was going. What is that? Right? So this goes this way. That's why it's called cross multiplying. That goes that way. Your equals is still here. Right? So 325 x equals 225. And now you just, beautiful little tiny equation, you distribute, right? Don't let this be a problem. All the bad stuff is behind us. This is the easy part now. Right? Distribute, subtract, divide.
So the question,
What do you get there?
225x plus 500.
25x plus.
Alright, 225x is nice. People going to help you out? Yeah. 225 times 20?
50.
225 times 2 is 450, so 225 times 20 is 4500. Subtract, get 100x, divide by 100, get x is 45. All right, you guys can finish that out. What does that mean? You get x equals 45, what's that mean?
That's the.
Kilometers faster.
No.
That's the.
What does x mean?
The rate,
Just go back to how you define it.
kilometers per
It's the speed for
Alicia.
Alicia. So you can put right there. Alicia's going 45 kilometers per hour. Ryan's going, yeah, it's 45 to 20, 65 kilometers per hour.
That's
So if we just circle like 45 and 11 like that, we can mark those points off?
Yes.
Of course. Several problems. There's 2 answers to this question. If you at least put the units on there, that's one good thing, right?
Yeah.
But then you didn't tell me what that means. Who is that for? There are 2 people in this problem. All right, so 2 answers to this problem. You got to make sure you get the right numbers for the right people. Don't make Alicia go faster than she feels comfortable. That would be me. It's going real slow, exactly. Right? If you ever go to Canada and drive around. You'll feel like you're got 130. Yeah. Which is not really much. And then when you come back to America, you're like, holy crap, what's the speed limit? Oh yeah, it's miles an hour, shit. All right, that's the 2-word problems. What about number 7, the domain questions? What do we got here as far as time? Okay. How do I find the domain of this? What must be true?
2x greater.
Yes. Because in English, what's got to happen for an even root? The inside must be at least 0. So it could be 0 or positive. So the inside must be at least 0. So you can say it in English, you can translate that to Mathish, and then you can work it. So how do you solve that? Yeah, it's like, yeah. Exactly.
So, FX stands for What does that question actually say? The domain? Find the domain?
of the function, and that's what f of x is referencing. It's a function.
So all of those, you would just set them to 0 like that?
Nope. Not all of them. I didn't set it to 0.
Well,
Now you
So,
can put in a-
Just think about this on another level. What number are you, what kind of numbers are you allowed to put in here?
Positive.
Positive or at the least 0. So, what is the number that's currently in here? 7 minus 2x. That's a number. I just don't know what it is yet because I don't know what x is. But it's a number. What must be true about that number? What did we just say? That number has to be at least 0 for this to work. So that's how I would say it in English. It's got to be at least 0, whatever you put in the square root. Well, that's actually exactly how you write it in math. And then you just solve it. How do you solve this?
why do you gotta give it 0?
2x.
What's the square root of negative 4?
2.
It's not real.
Negative 2 times negative 2 is
4.
not that.
Not
Oh, we
real.
got to, I learned this.
So this is not real. This is what's
It's
called
not real.
You got to
complex.
do the I.
Yeah, the I. So right now, if you know it, just let go of it. It's just not real. That's all we care about. So when I say find the domain, I mean what real numbers work here.
So since everything from 0 up is a real number, you start at 0?
But this, if I put a 0 in x, it actually starts at 7. What if I put a 3 in? What do I get inside?
That'd be negative 6.
Yeah, 7 minus 6 is 1. What if I try to put a 5 in?
Minus
It would be
3.
a negative.
That's too big. So my domain is going to be up to a certain value of x. There's some certain value of x that I can go up to. I can put as big negative as I want to in there because minus a negative would be plus, and then that is guaranteed to be a positive number in there. You guys see? Do you have to be able to do everything I just said? No. Solve this. It will tell you what's got to be true about x. How do I make this do this? Solve. That's what solving an equation does. It tells you how you make this true. Whenever you solve an equation, when I solve this equation, I say, okay, that number is what makes this true. So I want to make this true so that this thing actually exists.
So you flip the 7 over, make it a negative 7,
Okay?
and then you negative 2x, divide the 2, divide by 2.
Less for
You change the sign.
Good. Flip it.
Yes.
So what did we just say? We couldn't go up to 5. We couldn't even go up to 4, right? Because 7 minus 8 would be no. I can go up to 3.5. Because right at 3.5, this thing becomes 0 inside, and that's the first time the square root works. And then any number below that, it'll still work too. That's what that means. I can plug in any number below or equal to 7/2.
But if you write it just like that, that's okay too.
That's beautiful. What do you mean? Just like that, yes.
Hey, you flip that sign around when you're dividing a negative only?
Dividing and multiplying negative.
Only a negative.
Exactly.
So positive, you leave it alone.
Exactly, because again, 2 and negative 1, which one's bigger? 2. When I divide by negative 1, what's this become? Negative 2, what's that become? Which one's bigger? What does the sign do?
Boy.
Done. I love it. Why does the sign flip? Because it does. I love it. That's the legal correct answer. Because it does. Since it does it for numbers, it's going to do it for letters because letters are numbers. I don't know. So whenever you divide and multiply by negative, you got to flip that inequality around. Yes, ma'am.
Will we always use 0 then to figure that out?
Yes. If you have an even root, you pretty much will always set that grade equal to 0 solve. Now what's different with part B?
Not an even root.
It's an odd root. What the hell does that mean?
Means you need
Remind me, what's the cube root of negative 8? Negative 2. So do odd roots have issues?
No.
No. So what's the domain here? Is there any x's I'm not allowed to use?
No.
No. Why was this one restricted? Because the even roots can't handle negatives inside. Odd roots, whatever, man, throw it in there. Again, so this will be all real numbers. Or you can put negative infinity to infinity. Or you can put r with the extra spine on it. That means all real numbers. You didn't know that?
Start with the what?
I didn't get that.
R with the extra spine. Right? It's like, it's a quick way to say all real numbers. It's just R with the double spine. Just to let you know. So come on. Math people don't like to write, remember? There's too many letters in this. All right.
C.
I'm desperately trying to finish this answer key out for you guys. 7C. So what's the restriction on the kind of thing like 7C?
No solution?
That x cannot be, you have to factor, so x.
No. So more generally, when I have, what is number 7C? What kind of thing is that?
It's when
If you made X a number, you would get a, if you made X 7, what do you get? 6 over something. You get a fraction,
Zero.
right? So what cannot happen in a fraction?
undefined.
That the denominator is.
The denominator cannot be
Zero.
0. Okay. So when you see a rational expression, when you see a fraction with variables in it, in English you say the bottom cannot equal 0. And then you write that in math. What's the bottom? Guys, hey. What's the bottom?
X squared
X
minus
plus
5.
7.
So let me write it in English. Bottom can't be 0. So the bottom is x squared minus 5x minus 84. Can't be.
0.
How do I write that in math?
Less than 0.
Not equal to.
Yes.
So it doesn't say less than, it doesn't say greater than, it says can't be 0. It could be negative, it could be positive, it just can't be 0. How do you solve that? Factor it, good. Right?
Yeah, x minus 12.
Good.
X plus 7.
Kick ass.
And so when you get the answers, do you just get the answers and that's it?
Just treat it as a
Yeah.
normal.
If you, as long as you use that symbol.
X equals 12.
Keep going.
Oh, I
So
have to use that
x
symbol?
not equal, but x can't be 12. X can't be
7.
negative 7. There, that's the domain.
So,
The domain is all real numbers except those two things. So if you put that, that's fine with me.
What about the top that though?
Okay.
we're just figuring out.
The only way a fraction can be undefined
Is the denominator.
is if the bottom is 0.
No, I mean, if it's got x minus 1.
I know, but why do I not give a shit about that?
I don't know.
The only way to make that function have a problem is to make the bottom 0. The top can do whatever the hell it wants to. Right? The top can be any number it wants to be. Even if it's 0, the answer's still going to just be 0. Who cares? The bottom can't be 0.
Oh, so I guess
I desperately want to.
we're not solving it,
I
we're
did
doing
it
the
twice
domain.
and I don't know very much.
I'm trying. Here we go. Number 8. Now think about it. I'm not even sure if I. Hopefully this doesn't work. That'd be nice. Alright. So how do I do this?
You can get 5 and 2 and so
I
forth.
don't know.
Be more specific. Which letter do you want to kill?
Kill A.
Something.
A. I like Carl's got a good idea. Let's go with that. So I can take the first guy and do what with him?
Multiply by 2.
Multiply.
Yeah. So I can take twice 1 plus 2, right? Because they already have different signs. So I can do twice 1 would look like what?
2a minus 4b plus 8c equals 60.
So that's twice 1. Now what's
Minus 2.
and 2 I leave alone. Because it's already got negative 2a. It's exactly what I want. So what again when I put those together?
Minus 3b
Minus 3b.
plus 9c equals 12.
And that's my fourth equation. That's a good little dude, right? So you guys might notice something you could do, but we'll worry about that in a minute. How else can I kill A?
The first and the
First and third, right? So the first one I'm going to have to multiply by
minus 5.
negative 5 to kill that 5, right? So I have to do 5, negative 5 times 1 plus 3. So what's negative 5 times 1?
Negative 5a plus 10b minus 26 equals minus 40.
Good. So be real careful. If you have to, just write next to it negative 5. Put negative 5 next to each one. Because people always forget to multiply that guy or something, and then you get weird ass answers that I did not intend. The third one I leave alone.
So we just copy it.
Say again? Oh yeah, just copy it down because it's already got that 5 I want there, right?
And we call the A.
So the A, guys, again, that's the important part. Kill the same letter twice. Some of you guys kind of like work around yourselves. I'm like, damn, it never gets anywhere. Kill the same letter twice. Then you get 1, 2 equations with B and C in it. And then I can just directly kill those. So what do I get here?
11B.
Minus 31.
That looks yum.
That's
All right.
where I got it wrong.
Now real quick, what can I do to this equation to make it look a little bit better?
Divided by 3.
Yeah, divide it by 3. Good. So if I divide this by 3, I'm telling myself every step what the hell I'm doing. Right? Makes it easier for me and you. This will be negative B. What time is that? I'm going to start getting antsy out there. Plus 3C equals 4. Oh, I can't do anything here yet. So what do I have to do to this guy?
Multiplied by
Times 11. So let's see. I leave this guy alone. So we will have about 7 of these problems. So negative 11b plus 33c equals 44. Just very quickly. Those go away. I get 10c equals 10. C is 1. Thank God. Yeah. Plug it back in here to figure out what B is. Plug B and C back in one of these to figure out what A is.
It's just after 3, you do something
I have
that
one question. In the one that we did before, because the way I solved it is like the values can be 0, so I solve for the ones that make it 0.
Okay. But when I say find the domain, you have to say everything except what you found. Because otherwise you're telling me that only those work. But it's really only those don't work.
Yeah, that's
Yeah.
why I got confused, like why do I say.
So when I say find the domain, you got to tell me everything that works. So the one way to do it is to find the things that don't work and say everything else. Yeah.
And the way to say everything else, would I put like.
You can actually just say everything else. Or x not equal to, like we have here. That implies that everything else works.
I scheduled my test.